Hello, class. We're back here with some more examples of u-substitution. And I would encourage you, by the way, before you watch all of these videos of me going over u-substitution, to start doing some of the web work and see which of them you can pick off. Just try and do some of them here and there and see if you can figure it out. And if you sort of interweave doing some examples with watching me do some more examples and back and forth, I think you'll find you'll learn the most that way. I'll note, later in this week's videos, I'm going to talk about how to handle definite integrals with u-substitution, so don't worry about any of those yet, but these indefinite integrals, you can do all of them now, but I'm going to do a bunch of these so that you have a lot of examples to look at as you sit down to do these this week. Okay, so here we have yet another integral, and so we've got an x squared times the square root of 3x cubed plus 7. So I want to figure out as my u what thing here looks like it's inside something else. So the thing here is that the 3x cubed plus 7, that is inside the square root, so I am going to grab that. And if that's the case, then the derivative of that will be 9x squared dx. Don't forget the dx always goes here when you take the derivative of this thing over here. Okay, so let's look at this. Okay, so I want to try and reorganize my pieces here. So I'm going to have an integral. Let's see, there's the square root of 3x cubed plus 7. I'm going to write down my dx. Let's see, I'll put this x squared in front of the dx. But then I actually need a 9x squared here. So I'm going to need to put a times 9. But remember, I have to pay for the 9 with a 1/9 out front here. Okay, and so now I have everything set up so that everything will go cleanly in terms of my u and du. So this is 1/9 times the integral of the square root of u du. Okay, so that, remember, that is 1/9. By the way, one of the easiest things to do is what I just tried to do there, is to just lose the constant. Try not to do that. Go back and make sure you're keeping track of it. Okay, so what do we have? We have 1/9 times the integral of u to the 1/2 du. And so now this is a power rule question. So this is 1/9 times, and u to the 1/2 plus 1, that would be u to the 3/2 divided by 3/2 plus c. And so this will be 2u to the 3/2 over 27 plus c. And so our answer here will be 2 times 3x cubed plus 7 to the 3/2 power, all over 27 plus c. And again, just remember this u-substitution question, like all u-substitution questions, is basically just a glorified way of guessing and checking what our answer ends up being. So here it ended up being this. You probably would have had to make a lot of guesses in order to guess that that was exactly the thing you needed in order to take the derivative of in order to get that. But here we sort of went more or less straight to it. Okay. Let's do the integral of the cosine of the square root of x divided by the square root of x dx. Okay, so what's my inside function here? Well, not a lot of options. I guess I'll go with u is the square root of x. So if u is the square root of x, then du is 1 over twice the square root of x dx. So this requires actually a little more work here to make happen. Okay, so this is going to be integral of cosine of the square root of x. I know what I'm going to do with that, times. And so if I look at my dx here, I have 1 over the square root of x. This here, so far it's the same exact thing as this. Cosine of the square root of x divided by square root of x is the same thing as cosine of square root of x times 1 over square root of x dx. Okay. But I need a 2 here, which means really I need a 1/2 here in order to make this a 1 over 2 square root of x. But if I want a 1/2, then I have to balance that out by multiplying by 2. Okay, so this is kind of the opposite of what we've been doing. We've typically been getting something like a 9 here and then paying for it with a 1/9 out front. Here we're buying a 1/2 and we're paying for it with a 2 out front. Okay, and now this is all cleanly going to turn into 2 times the integral of the cosine of u du. Okay, so beautiful. We've gotten rid of all of our x's. They are all now gone. So we can now just integrate the cosine of u du. And so that will give me twice the sine of u plus c. And so my answer to the question, once I translate back, will be twice the sine of the square root of x plus c. Okay. Do one more example for this video. We'll do the integral of 6x divided by x squared plus 1 dx. Okay, so here is one where there's no obvious function to say is sitting inside of another function. But here's a piece of advice. When you're looking at a fraction and you don't have an obvious inside function, then what do you want to do? You want to take u to be the denominator. Okay? Because anytime you have a denominator, that thing is sort of secretly sitting inside the function 1 over x. That's sort of the reasoning why. So I'm going to take u here to be the x squared plus 1, thinking it's really sitting inside this kind of function, even though I don't see it as blatantly as some of the others. Okay, but if I do that, then my du here is going to be 2x dx. And so now if I try and rewrite this, I'm going to have an integral here of, and so I'm going to rewrite this as 1 over x squared plus 1 times 6x times dx. Again, this is the same thing as this. But I really don't want a 6x dx, I really want a 2x dx. But actually here I can make that happen without doing any borrowing. I can just factor the 6. And so I can rewrite this as 3 times 2x dx. And so now that is my du, and that's my u. So this will be the integral of 3 over u du. Beautiful. And now, again, I've gotten rid of all of my u's. And so this is now a power rule question. But remember, this is the one particular case of the power rule where things work out a little strangely. Because the integral of 1 over u is going to be the natural log of the absolute value of u. So this is going to be 3 times the natural log of the absolute value of u plus c. And then last up, you have to remember that you have to substitute everything back to the language that it was in before. So in this case, this is 3 times the natural log of the absolute value of x squared plus 1 plus c. And a thing you'll often see is people will notice if they're looking at a question like this, that x squared plus 1 itself is always positive, because you square anything, you get a positive number, and then you add 1 to it, you get a positive number, so the absolute value of that will be positive, which means that these absolute values are here actually not doing anything. So you'll see a lot of people will rewrite the answer to this question like that, as a form of sort of subtle simplification. All right, we'll wrap up the video there for now. I'll pick up in the next video, and I will do more examples of u-substitution. But until next time, be well.